Uh, Good morning to everybody. Okay, now we continue with our third session. In this third video, okay, I will discuss about the toughness and strain hardening as I promised in the previous videos. Okay, what is the toughness? Okay, toughness in tensile test refers to the area under stress strain curve. Okay, I think these properties you already learned in EBB 113. When we talk about the toughness uh, in the stress strain curve, okay, as you can see in the figure at the right side here, you need to see my mouse here. Okay, uh, you in this stress strain curve, you have the material A and B and material B asterisk. Okay, in this case, you can see how the the toughness property of material B and B slash. Okay, in this case, as you can see, uh, when we talk about the toughness in stress strain curve, it refers is the area under the curve. Okay, as you can see here, the material B, you can see the blue color line. Okay, it reached until here and then suddenly failed. Meanwhile, for material B slash, okay, the sample is elongate, okay, elongate in elastic region, and then they convert into the plastic region, reach the maximum UTS, and then start to fail. Okay, as you can see, the area of the curve for material B and B slash, okay, you can see for B slash the area under the curve. You can see the red zone here, okay, refers to the higher value of the toughness when compared with the material B. So therefore, for this graph, we can conclude that the material B slash, okay, shows the higher toughness when compared with material B. Okay, so in other words, toughness is the ability to absorb energy up to fracture. Okay, also the tough material has strength and ductility. Okay, I think in the second video I already mentioned about the ductility, how to measure the ductility by calculate the percentage of elongation. As well, you need to calculate the percentage of area reduction. Okay, this one example of the different toughness of material. Okay, you can see for ceramics, okay, the toughness is the lowest compared with metals or polymer metric composite, as well the unreinforced polymer. Okay, unreinforced polymer means uh, polymer pure. For example, you have PLA, PLGA without the fillers. Okay, because the fillers give the strengthen or the improve the mechanical strength of the polymer. That's why in polymers, okay, you can adjust the toughness by adding a certain amount of fillers. Okay, now I want to talk about the strain hardening. Okay, strain hardening means that the tendency to harden. Okay, I want to attract your attention here. Okay, this question is quite popular in the past year as well for tests. Okay, you need to understand how to use the strain hardening equation. Okay, for strain hardening, you can see here the equation is the true stress equal C epsilon T and apostrophe N. Okay, so this normally in equation they give you this n value, and this one C is the constant, or you can see C is the slope of the graph. Okay, so you can see you can learn from this graph. Okay, so you have, for example, we have two example here, the blue color and the red color. You can see the graph difference. Okay, as you can see here, as I mentioned, the strain hardening occurs in the plastics region. Okay, meaning when they reach the yield point here, you can see the yield point, and then they start to deform. Okay, as you can see here for the blue sample, for the blue example, when they reach the yield strength and then they suddenly constant. Constant means that, meaning that when you pull, uh, they're still there. Okay, not so change, not so good the condition. Meanwhile, for red sample, as you increase, okay, they're meaning that you can uh, pull more as well, and then later you can shape into the different sizes or shape. Sorry. And then when you increase this, okay, so meaning that the large hardening, so you have the ability to shape or to mold the metal. I think in the previous second video, I think I shared with you the example in the string hardening condition, what we can do, something like fogging, rolling, tempering, or molding, okay, to get the desired shape of the metal. Okay, here the example of the strength hardening equation. Okay, I put remarks here is important. Okay, is important. So meaning that you need to I can say not remember, but you need to understand this equation where you should use the true stress, where you should the true strain. Okay, and normally the end value will be given as you can see in the question here. Okay, so you need to watch a few example in website how this equation has been used. Okay, I stress again, you should understand this equation. Okay, I think that's all from the third part of my section. Okay, later I will show with you the fourth part of the topic covers the bend test. Okay, consisting of flexural strength. Sorry, flexural test for the method. Okay, please stay with me. Thank you very much.